The derivative of the hyperbolic sign is cosine, hyperbolic cosine, and therefore the antiderivative of the hyperbolic cosine will be hyperbolic sine. The derivative of hyperbolic cosine is hyperbolic sine, and so the antiderivative of hyperbolic sine will be hyperbolic cosine. And the derivative of hyperbolic tangent is hyperbolic secant squared, and therefore the integral or the antiderivative of hyperbolic secant squared will be hyperbolic tangent. And then the other formulas we have is antiderivative of hyperbolic cosecant times hyperbolic cotangent is negative cosecant, hyperbolic cosecant. An antiderivative of hyperbolic secant times hyperbolic tangent is negative hyperbolic secant, and it comes from this formula right here. And an antiderivative of hyperbolic secant squared is negative hyperbolic cotangent. So we have the integral of hyperbolic sine of 2x, and so we want to find this definite integral. And so here we need to use the u substitution method. And so we will let u be 2x, and therefore du dx will be 2. And so we have du is equal to 2 times dx, and then multiply both sides by 1/2. And now this becomes 2x is u, and then dx is 1/2 du, and then we can move the multiplication constant 1/2 and place it in front of the integral. And we have antiderivative of hyperbolic sine is hyperbolic cosine. So we get 1/2 hyperbolic cosine of u, and then this is 1/2 hyperbolic, but u is 2x, and then plus c. So this is the answer. Here we have the indefinite integral of hyperbolic secant squared of 1 minus x. We have the formula hyperbolic secant squared is equal to hyperbolic tangent. And so we need to use the substitution method here. So we let u be the 1 minus x. So du dx is negative 1. Derivative 1 is 0. Derivative negative x is negative 1. So we have du is equal to negative 1 times dx, and then multiply both sides by negative 1. Then we'll get dx. And then now we can make the substitution. 1 minus x is u, and then dx is negative 1 du. And negative 1 is a multiplication constant, so we can move it and place it in front of the integral. And the antiderivative of hyperbolic secant squared is hyperbolic tangent. And this becomes negative hyperbolic tangent, and u is 1 minus x. And that's the answer. Here we have the integral of hyperbolic cosecant squared of 5x minus 10, and we want to find this indefinite integral. We have the formula of antiderivative, or the integral of hyperbolic cosecant squared is negative hyperbolic cotangent. So again, here we will use the substitution method, so we'll let u be the 5x minus 10. So du dx be 5. Derivative 5x is 5, derivative 10 is 0, and so we just get 5. And so this means du is equal to 5 times dx, and then multiply both sides by 1/5. And we get dx. And so this now becomes the 5x minus 10 is u, and then the dx is 1/5 du. And 1/5 is a multiplication constant, so we can move it and place it in front of the integral. And then this becomes 1/5. And then the antiderivative of hyperbolic cosecant squared is negative hyperbolic cotangent u. And this is equal to 1/5, and the negative 1/5 times the negative being negative, and then we have hyperbolic cotangent. U is 5x minus 10. And that's the answer.